So today we're going to take a look at how to actually model exponential relations for particular types called growth and decay models. So growth is just an exponential relationship that is expanding, that's growing, and decay is an exponential relationship that is decreasing or decaying, going down. And so what I want to take a look at today is I want to take a couple of examples. We'll look at things as they relate to, say, interest and money, but we'll also take a look at things like radioactive half-life or the half-life of caffeine in the body, and because we use these exponential equations for finance, we use them for science, we use them for medicine, and any number of things. Okay, so let's take a look at our first example. It says that the graph below here on the right-hand side shows Evan's investment over a period of 30 years. So an investment that you put some money away in a bank or the stock market or something to this effect, and it's supposed to, hopefully, it's going to grow. So we want to figure out, well, how much money did Evan start off with when he started? Okay, so what amount of money? So if we look here, the starting amount of money, the initial value, that's known as our starting value. And so every time that we're using exponential equations are always written in the form y equals a times b to the exponent x. And what's really important is that our initial value is right there. Okay, the a value is the initial value. That's the starting value that we have. And so what I can do is I can change what my initial value is if I look at this graph. So my starting value is where the y-intercept is. Okay, the a value is also the y-intercept. And for this particular graph, the y-intercept happens right about here. Okay, and based on the scale of this particular graph, that's going to equal about $1,000. Okay, so his initial investment is $1,000. So we want to then extend this a little bit more and figure out, well, how much is Evan's investment worth after 12 years? So if I want to know how much his investment's worth after 12 years, what I need to do is I need to figure out, okay, well, down here, this is my time in years. Oops. So I want to record this as being my time in years, and this here is the dollar value, just so I've got my axes correctly labeled. So after 12 years, if I draw a line up, okay, it's going to intercept right at this point, and so I'm going to continue over, cross. Okay, and so this intersection at 12 years is worth approximately $2,000. Okay, and so what I'm going to expect for you guys to do on your unit test is to actually draw in the dashed vertical and horizontal lines that show the intersection of the axis with the graph. The next question says, how long has Evan's money been invested if he has $4,800? So I can do the same thing that I just did, just in reverse. So this time, I'm going to take a look at $4,800, and I'm going to do my dashed lines coming across. And then I'm going to go down. So right here is roughly where it intercepts. Oh. So it intercepts roughly about there. So I'm going to go down. Okay. And that's going to end up roughly at about 27 years. So approximately 27 years. So approximately 27 years is how long he's had his money invested for. Okay, so one thing that we want to summarize here is that an exponential equation in this form of y equals a times b to the exponent x, we can use that to model all kinds of real-world problems. So again, y is always the final value, the ending value that we have. A is our initial value, it's our starting value. It's also known as our y-intercept if we're graphing it. Okay. B is either the growth or the decay factor, so how much it's growing by or decreasing by. And so growth is, say, 1 plus the rate of decay, or sorry, 1 plus growth is 1 plus the rate of growth. So 1.6, for example, would be a 60% rate of growth. You always take the growth rate as as the decimal value of the percentage. So if the growth rate is, say, 3%, as a decimal, 3% is 0.03, because 3% divided by 100 gives me 0.03. So the growth rate would be 1.03 to the x, okay, if it started at 1. Okay, and so in this particular equation that we have, that's listed down for us at the bottom, we can identify a couple of things. One, we can identify our A value. That's the A value. Okay, and so the y-intercept is going to be 1,000. We can tell what our B value is going to be. Say our B value is going to be 1 plus, so I know it's a growth rate because it's bigger than 1. So 1 plus 0.6. Okay. And so 0.6 as a percentage, if I wanted to figure that out, would be 6%. Okay, so we always express that as the decimal version of the percentage.